Uh, Thank you very much. I'm representing Group DevOps Malmö, so hello everyone, and welcome to our next presentation. And I know you in the live stream are going to watch, so hello you too. So there is some practical things we will discuss before the actual presentation, okay? So one of them is going to be talking about our group, and the rest is how you are going to ask questions and etc. So for live streaming people, if you have questions, you should ask in YouTube. So I'm going to watch it live. So if you have questions, just shoot it in the channel. For people here, if you are going to ask question, raise your hand and you are going to talk to microphone, okay? Because then there are people who are going to watch live, so we can share the question. All right? So I will talk about DevOps Malmö Group. We are organizing tech events since 2018, I think. It's been 4 years we are organizing. And we have some social media links that you can use to contact us. And one of them that is mainly used is GitHub. And there we do, we call it Meetup Ops. So we have a README where we try to call speakers there. And it's super simple README. You can request a call, or if you have some venue, you can just add your venue there. The other important places where we do most of the promotion is Twitter and meetup.com. We have Instagram where we like more or less trying to be active, which is not that technical. But if you say, I don't want to be in any social media, it's completely fine. We don't force anyone to subscribe or register, nothing. Foo Café has open page, so you can just go there or just watch live stream every time. You don't need to register whatsoever because it's live. All right? So all the possible options, and if you think you have a cool company, try to bring us as speakers. All right? We love to share the knowledge, and sharing is caring. And if you think your company is double cool company, all right, try to sponsor Foo Café. And therefore, we want to thank Foo Café for organizing all this. All right? Let's thank Foo Café. Yeah. All right. Thanks. One last thing I want to speak about is this is not our last event. It's going to happen one more this year at least. And it's going to happen in 7th of April this year. And it's going to be about introducing rule-based refactoring. Good. So if you haven't signed up for this, it's public in meetup.com, in Foo Café, and everywhere where you can find us. Cool. It's time for starting the actual presentation. So I'm going to hold this microphone with me, okay? So in case of questions, try to somehow wave it to me. All right? Thanks. So, Lars?
Yes.
Stage is yours.
Cool. Thank you, Karen. Awesome. Yes, please hold on to that microphone. I would love to get questions when you think of them, because, I mean, it's a presentation. It's like 45 minutes long, so if you have any questions, I'd love to hear them, because, I mean, yeah, that's... If you wonder something, odds are somebody else wonders the same thing as well. Karen, will you be reading questions from YouTube as well?
Yes. So I'm now going to put my phone to be live watching the stream as well. Cool.
Awesome. Okay. Thank you so much. Yes. So welcome to this presentation called Principles for Designing and Deploying Scalable Applications on Kubernetes. And thank you so much for joining us here in person and also on the live stream. I think this is amazing. I'm so happy this is the first physical, like in-person event I've had in such a long time. And it's wonderful to see such a big turnout here. So thank you so much for being here. Right. And of course, thank you Foo Café, and thank you DevOps Malmö for hosting this talk. So who am I? Well, I'm this guy, Lars Larsson. I'm a senior cloud architect at Elastisys, which obviously is a cool company because we're here, right? We have office in Umeå in northern Sweden. That's where the company is from. It also celebrates 10 years, actually. Yes, thank you. Just like Foo Café does. And we also have an office here in Lund, close to Malmö, as well, since a year or so back. I've been working in cloud since 2008, and I've done so both in like industry and in academia. And I would love to connect with you on LinkedIn. So please if you think this talk is interesting, then please connect with me on LinkedIn. If you want to look at these slides afterwards, by the way, and if you find any of the links interesting, the slides are actually, I've linked to them in a comment on the meetup page. So you can just go there and you'll find them. All right? Electronically, and then you can click on them. So, what's the goal of this talk? Why are you here, essentially? Well, I'm here to give you actionable advice. That's the whole point. How to get the most out of your Kubernetes platform, how to clearly express what it is you want to achieve, so that it can actually help and support your applications. So, Kubernetes is a wonderful platform, but unless you're actually talking specifically to it, it's not going to be able to support you in doing what you want. And the whole point of Kubernetes, the whole reason why you adopted it in the first place, or why you're even thinking about adopting it now, is of course all the automation features that it can offer. And obviously that takes some preparations as well. So basically we're here to learn how to speak to Kubernetes, essentially. Yeah, so that's the whole idea, to give you the tools that give you what you actually wanted with Kubernetes. So let's begin. I'm just going to dive straight in, by the way, because this is, it's 15 principles. The first ones are sort of like warming up round. It gets more technically involved after that. First point is that a single pod is pretty much never what you want to use. And if you are a Kubernetes user already, then this is probably familiar to you because you realize that yes, I need to run multiple pods probably, but I also need to have them managed by something called a deployment, a stateful set, or something similar. You will find tons of documentation out there which talks about here's how you just easily create a pod and like start to access it and play around with it. But that's never actually what you want to do in production, because the reason is that Kubernetes gets to terminate pods as needed. So whenever it feels like doing some kind of scheduling decision, it can actually terminate a pod. So they're useful for debugging purposes. So say that you have some microservice or whatever deployed, and you want to start a new pod so that you can get in there and access the same network as a pod that might be failing somehow, so you need to debug it. Then, of course, yes, you can use a single pod because it doesn't matter, but you're never supposed to run your production workload in a single pod. So the idea is let deployments or stateful sets manage your pods, even though you might just need one at a time. This is not at all difficult. Obviously, there's a huge impact because if you would screw up and actually use a single pod, you'd be in a world of hurt. So this is very easy to do. Point number 2 here, or principle number 2. Clearly separate stateful and stateless components from each other. Now, the Kubernetes part of this is of course very easy because it's just a matter of choosing, deployment or stateful set. And stateful set is a more stable way you get certain guarantees around stability, and stability here means consistent across pod rescheduling. So you get stable, unique network identifiers, so essentially host names, storage. They have a number, so you get ordered deployment, scaling, and rolling upgrades. So if you make some kind of change to the stateful set, if you say you're rolling out a new version, it's not going to happen all at once. It's not going to be like replace all. It's going to actually happen in the order that is well defined. And you also get a certain amount of stickiness in scheduling pods to nodes, in the sense that Kubernetes will not really try to reschedule a pod to a different node unless that node gets deleted. So you get a certain amount of stickiness here. Now, okay. Why do I say this is difficult? Because, I mean, it's basically just switching out one word for another word in the YAML file. It's not difficult at all in the Kubernetes sense. It's very difficult to take, say, a monolithic service that mixes both stateful information and has has stateless aspects to it as well, and actually split that apart. That's a architectural decision that you need to make. That's not so easy. Has anyone done this migration from monolith to microservices here in this room? Yes, a few. Was it super easy? Oh, that's wonderful. Yeah. So in that case, it was easy. I'm happy to hear that. Your experience is probably not typical. Let's just put it that way. No, but yes. So it's something that has huge impact because obviously, I mean, it's wonderful if you tell Kubernetes these are the stateful components, these are the stateless components. Yes, wonderful. A question. Microphone, please.
Can you explain some examples what kind of services is useful to use the stateful set or deployment?
Absolutely. That's a wonderful question. Yes. So if I were to run, say, a database, and I would like to have that database run in a clustered way, so that maybe I want so maybe I do it for performance reasons. So I have 3 replicas, and I want them to handle different data, so like different subsets of the data, which in databases is often called sharding. So I want to have this one deal with one shard, this one another, and this one a third. I probably need to tell each database replica, here are your 2 buddies, and they are handling these subsets of the data. They have these shards. It's very useful then if across scheduling decisions they have persistent host names. It's also very nice if they are persistent with what storage gets attached to them, because you really want this shard to, if it gets restarted, to actually know what data it has, which shards it should find in its sort of persistent volume. So for that reason, stateful set is very, very useful. Deployment is useful basically when you just want to run multiple replicas or multiple instances of a certain component, and that component can be a stateless component, say a web server, something that consumes work from a work queue, where you don't care about the actual identity of that instance. You just want a certain amount of them. Does that answer your question? Wonderful. Oh yeah, and please keep checking YouTube to see if people ask questions over YouTube as well. So, number 3. This is sort of the last very easy thing here. We're going to get more technical, or it's going to be more complicated in a short while. Please separate all secret from the non-secret configuration. And I see this a whole lot, that people don't really do this. I mean, everybody here in this room obviously does, I'm sure. But I mean, you should know the difference between config map, which can contain any kind of configuration. So can a secret. What's the point of using a secret instead? Well, I mean, it can be encrypted, so it can be stored encrypted. It's also not going to be just as easy to look at and visually inspect and say, I see the password stored in the secret. But I mean, that's not necessarily the strongest case for it. The whole point is that you can have role-based access control in your cluster. And I hope everybody has role-based access control enabled in their clusters. Kubernetes has this wonderful idea about security, that it doesn't need to be secure by default. It just has settings that you can enable to make it more secure. One of them being role-based access control. It's very nice to be able to say that, okay, these developers get to change as much configuration as they want, but perhaps in the production environment, we only allow certain operators to look at or to modify these, say, secrets, these connection strings to databases or whatever. Maybe you need to do that for compliance reasons. Who gets access to what? And then it really makes sense to have secrets. Now, okay, so something that also always comes up when I talk about secrets with customers is they ask, well, how am I supposed to even deal with secrets? What, I mean, a secret, if you read the documentation, you see that, oh, okay, so it's like what, base 64 encoded or something? I mean, that's a joke. That's not, and where am I supposed to put the secret? I mean, do I need to run like Vault or something to store my secret in, or do I have to depend on whatever service there is from the cloud? No. There's this wonderful thing called sealed secrets that Bitnami has developed. So essentially it means you encrypt a secret, and you can then take that encrypted secret and you can put that into your Git repository as much as you want, because it's only going to be the sealed secrets controller running inside your cluster that can actually read that secret. That's pretty cool. So, yes? Is it a question? Because then take the microphone, please. Yes, we'll take the microphone.
Hello. Okay.
Yes.
Cool. The wonderful things and stuff with sealed secrets, just a like real world experience. The difficulties of seeing the data represented is difficult with sealed secrets. And if you have a UI with access to the controller, you can still see the data. For example, in Rancher, if you have like a Rancher UI has access to the controller, you can in the UI with a different kind of RBAC, you can see the real data.
Oops.
Yes. So, depending on your implementation, it can be not so wonderful and not so secure as one would imagine. But the theory around it is nice.
Yeah. That seems like a major oversight to actually make it possible to look at the data via some kind of side channel, something protected with a different RBAC rule. That sounds very strange.
Yeah, we loved it.
Yeah, I bet. Yeah, sure. Yeah, absolutely. You got a YouTube question. Wonderful. Thank you, people of YouTube. Okay, no.
It's me, myself.
Okay, thank you, Karen.
Yeah. So in this case, this sealed secret is deployed as controller. So is it like how do you get access to the secret? Is it only deployment that you do as controller, or is it like sidecar? Is it like a
so basically it runs, think of it as an agent. So some kind of component runs in the cluster. It has private key, public key. When you want to create a sealed secret, you encrypt it with that one's public key. So, I mean, you can create the encrypted one, but only that one can read it. And then that can read it and turn it into, can decrypt it and then make it possible for your pods to get access to the decrypted version of the same thing.
Because theoretically, what I always I have a lot of issue with secrets. So what I try to solve, okay?
Yeah.
So at the end, you always have one secret that is still base 64. At the end, because that's your public key in this case, or
yeah, but public key is fine. Public key is totally fine to distribute everywhere. I mean, I can have a T-shirt with my public key. I mean, it's going to be the nerdiest thing you'll ever see.
Sorry, private key. So, but somehow you need to tell that your application or controller has access to actual secret. No, so there is at least one thing is. But how you're going to talk to the engine that is going to decrypt it? There is at least you have to have something that is unique.
You always wind up with this. Yeah.
Okay, because all the time you have to have something that identify you that you can decrypt. So at the end you are scaling down the whole picture, but still you are not solving it completely, because at the end one identification is always in base 64 in Kubernetes. Still.
Sooner or later, you always, I mean, that's also the case if you look at all these cute, secrets services of the big cloud providers. I mean, sooner or later, you have some kind of master key that basically you need to have stored like in printed form somewhere in a bank. I mean, basically you always have that problem. You're kind of pushing it further away from, so that it's always supposed to be difficult to get to it. I totally agree, but that's, I mean, okay, this is complete tangent here, but that's basically the whole point of security, isn't it? I mean, my bike should have a strong-looking bike lock, so they steal yours instead, right? So security is always about making it difficult to do the wrong thing, but yeah. Of course.
Hi.
Hi.
Regarding the sealed secret,
Yeah.
you mentioned that I can therefore store my secrets encrypted in the code base.
Yeah.
How does it work with key rotation?
How does it
Like
work with what?
That thing will rotate the private key. Is there a rotation in place?
If the controller port, I mean, if that one gets compromised, then you need to rotate. Then yes, I mean, you need to recreate the secrets so with the new key. I mean, it's basically.
But in that case, it's like one unplanned key rotation.
Yeah.
I'm a bit maniac when it comes to key rotation. Had bad experiences.
Sure.
So that doesn't automatically rotate like with the transition between two keys or stuff like that. I'm asking because
I don't believe it does, but I'm not sure.
Okay, thank you.
Need to look that up. Yeah. 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 I'm not sure if people on the stream heard this, but we have comments here saying that, yeah, maybe it is possible. And maybe it can actually do that, to auto-rotate secrets itself. Yeah, that would be wonderful. And I would love to check that out. I'm not entirely sure. So, I mean, if you use that sort of like, that's one of the brain point, but I mean, if you even say, if you go the route of having sealed secrets and that's what you choose, maybe you can also completely forbid checking in secrets altogether via some kind of policy as code. I mean, either you like forbid it from ever touching your Git repo, or you even forbid it from ever entering the Kubernetes API, just as part of calls that you issue. Okay, those were the first three. It took a while, but let's go to capacity management, which we kind of need here to make good time. Enable automatic scaling to ensure capacity management. So auto-scaling. Kubernetes has auto-scaling. It has the horizontal pod autoscaler. So, I mean, you can scale the number of pods in both a deployment and in a stateful set. The latter can actually surprise people. Yes, you can auto-scale stateful applications. However, proceed with caution, because if you scale up, say, a database, going back to that example, if you scale up a database while it's currently being just hammered with tons of load, and there would be, say, data replication needed as part of starting a new instance, because well, how else is the new instance going to do anything? Or like reshuffling if it's sharding. That actually might be a big problem to have that happen while you're currently under heavy load. Also, it can be a bit difficult to scale down. So, I mean, you can totally do it, but just be mindful about any difficulties that you might run into. Okay.
I think you should keep this with you, okay? Keep it on.
Yeah. So conversion between, so your conversion between a monolith and microservices was easier than actually getting all scaling in place. Yes, I totally understand that. It's not easy, but it's very powerful. And what I think is actually, I mean, let's jump back. What I think the really good part about this, I mean, by the way, this is all from an article that you can find on our blog. It's also been posted by the CNCF, so you can find it on their blog too. It's that I think you should always prepare to run multiple instances of your components. That is a great sanity check for you, because that means your architecture is well prepared to scale. If you can't, then figure out why you can't. It probably means you have some kind of stateful information somewhere, and it's probably not good for you, because anything that limits your possibility or ability to scale is going to become a problem sooner or later. Okay, it's always an indication of something being a bit wrong in the architecture. So if you can't run multiple instances of a thing, that's not great. And if you can run multiple instances of a component, then it would be lovely if there is also an auto-scaling rule in place, because why would you want to manually scale something if the computer could do it for you? Yes, I know, because it can be difficult. I also put difficulty quite high here. So yeah. All right. Who here knows that you actually have container lifecycle management hooks? So not just init containers. Okay, one person. It's not just init containers, which, so if you have a pod, you have something called an init container, or a set of init containers. Sorry, a list of init containers. Before the main containers in that pod start, or get to start, all the init containers have to complete successfully. And they can do certain things like, I don't know, like write configuration, or fetch the latest thing from a Git repo, store it on some file system. Fun things like that to really prepare so that the pod knows they can run. The same thing or similar things you can also do on a container level, where you have post, start, and pre-stop hooks. So you can actually define scripts that will run, so like post start, it will run upon container creation, and the container will not be considered to be running until post start finishes successfully, and it's going to get restarted if post start does not work. This is a great time, for instance, to check, am I able to connect to the database that I really depend on? Maybe I should scream otherwise in my logs. Pre-stop. So before Kubernetes will stop the container, before it will stop, each container in the pod, it can actually trigger a pre-stop script for you. This makes no sense if you have just a stateless database, a stateless web server or something. But if you have a database and you need to like flush all the data to disk, really make sure you've written all the data that you promised to write, this would be the place to do it. And this is, of course, also per container. So it's per each container in your pod. You can tell each and every container in there what its hooks are. This is really powerful stuff. And sadly, I don't see enough of it being used. I see tons of probes being used, however, but in the wrong way. Show of hands in here in the room. How many know the difference between liveness and readiness probes? Okay, 4, 5. 5 think that they know the difference between liveness and readiness probes. So liveness, so what I often see is that people write the exact same test for both liveness and for readiness, and they think that's it. That's what you're supposed to do because that's what they've seen as well. It's not. Okay? It really isn't. So in distributed systems, liveness means something. It means that you are not in a deadlocked situation. Deadlock being, like, I can't move until this thing is out of the way. And the other one says so too. So if you have a database, for instance, maybe like one transaction can't finish before another one, and they wind up in some weird, deadlock situation. How can you solve that type of situation? Yes, you restart the thing. Because basically, you're in a situation that the computer can't solve. It's not going to fix itself. You have to just cut it out and, restart and hope that it's not going to wind up in that state again. That's a deadlock. That's what liveness probes are supposed to do. If a liveness probe fails, Kubernetes is friendly and will restart the pod for you. That's the whole point of liveness. Readiness is probably what you meant. Readiness means that I can handle requests. So if a pod fails, if a container fails its readiness probe, that means that the whole pod is not ready. That means the service will not route requests to that pod temporarily. It's still going to get probed, and if it gets unblocked, because maybe it was a temporary issue, maybe it was a backend component and the database it needs to connect to do work, that was unavailable right now. Therefore, that instance can't do what it's supposed to do. Then it should fail its readiness probe, okay? So it should not receive any new requests because maybe there's a problem between just these two. So it causes a temporary removal from a service's endpoint. What's the problem that you wind up in if you have readiness and liveness set to the same thing? Well, first it's going to exclude it from the service, but it's also going to restart the thing. Was restarting it actually necessary? Probably no. Probably it just caused stress to your system. So don't do that. Liveness means a thing, and it's probably not what you meant. Oh yeah, and startup probe is the new kid on the block. It just holds off the other probes until the container is ready, and you can actually subject it to both liveness and readiness. So startup essentially means it should keep failing until the container feels like, yeah, okay, now I've started up. This is not at all difficult to implement correctly, by the way. I mean, you probably need to go into your YAML files and delete the liveness probe you have in there right now. So it's very easy to do, but the impact can be huge, because what I've seen tons of times is that this unnecessary restart that you wind up with is actually causing tons of unnecessary downtime. Because if it's just a temporary issue, readiness is the whole. Readiness will take care of that for you. It's going to exclude for a while, but then it comes back online. Don't restart your pods unless you actually need to. But if there is a problem, you should make your components fail hard, fast, and loudly. And what does that mean? Well, failing hard means crash the thing. Don't try to be smart. Don't try to promise to I'm serving these requests. I'm going to keep this. I'm going to get to whatever I promised to do later, I swear. Because where are you going to store that information if you then actually crash? No. Crash as soon as possible. Just be like, oh, I can't do this. So that's failing fast. Don't even try to be smart. Just crash. Because otherwise, you sort of make false promises. And you don't want to do that. And fail loudly, too. So scream in your logs, make it super clear to you yourself later, you the developer, what happened so that you can actually go in and fix it after the fact. Because honestly, components will crash. So that always needs to be an option. You can't make crash-proof software. Nobody can. So there will be crashes, there will be restarts. It's inevitable anyway. So it's actually a totally valid thing to do. If there's a problem, just crash. Prepare your application for observability. Okay, so observability, kind of a buzzword, monitoring, logging, and tracing. Monitoring being anything you can attach a number to, so like CPU usage, number of logged in users, errors in the last 5 minutes, that type of thing. Numbers. Logs being text statements that comes out of your application. Tracing being how you can actually correlate one request to one service with any follow-up requests across the rest of your microservice architecture or whatever you have. One thing that you kind of lost when you went with microservices rather than a monolith was the fact that now you don't have this nice debugger to go in and you can look at all the stack traces and stuff like that. You kind of lost that one. You gained a whole lot in like scalability, blah, blah, blah. I mean, you have your reasons, right? But you did certainly lose that aspect of it. Tracing, distributed tracing as it's called, you can actually get that back. And to do that, to be compatible with that, you just need to implement something called OpenTelemetry API. There are great libraries for doing this in basically all platforms, so just do that. Yeah, sure. Go ahead.
I have a question about this tracing between applications. Is this something that is that you get for free if you implement certain types of service meshes?
It sounded kind of on. Have the mic closer to your chin.
I'll repeat the question for everyone in the
Awesome.
audience. So if I want to do this distributed tracing in my microservices, would I gain anything by looking at different types of service meshes to help me to prepare for this? Or should I implement it entirely with software, or how should I do it?
You can get, okay. Quickly, how does it work? I mean, basically, when a request comes in and it does not have a specific HTTP header, some component will create that header with like a random number or like a one of those UUIDs or something, and then that will travel with any subsequent requests. It can create like sub requests as well. All that stuff goes into HTTP headers. Some service meshes will add that information for you, yes. So you can do that, but it's not like you need to run an entire service mesh to get this, because essentially all you need to do is like respect HTTP headers. So the low impact way of doing this would be to add support for the OpenTelemetry API in your code. But I mean, if you have a service mesh in place, yes, you'll probably get this for free. What's nice about actually having your software be aware of that is that you can add your own information to these requests. So you can actually like tag them, add additional information. What I see, also you can include non-HTTP requests as well. So for instance, information about the request that hits your database. Typically that's just done over TCP, so no HTTP headers will be there, right? What I think is really good if you do that is that maybe you don't include the entire query that you're asking, but maybe you include enough information about the query so that you can then later go in and look and say like, when we ask this particular type of query, I mean, don't include all parameters and stuff, but I mean, when we ask this particular type of query, apparently we have performance issues. So if you have that in place, that's wonderful for finding performance bottlenecks. I need to pick up the pace a bit. Go read 4 Signals of Site Reliability Engineering, or as I saw on a t-shirt, SRE could also be Server Reboot Expert. I love that one. And I mean, if you have really good application level metrics, maybe you can auto-scale on that instead. Like if you have something that consumes from a work queue, maybe you could scale on how quickly am I consuming from the queue rather than just like CPU usage, because maybe that makes more sense. Pods can be limited in how much resources they can request and how much they are limited to get. Please use this. So why? Well, first of all, it's just plain nice to specify this information because Kubernetes is essentially a scheduler. I mean, it has a scheduling component. Here's the size of your virtual machine. If it knows exactly how much of that to allocate to pods, it can do a much better job at figuring out, like, do I have sufficient capacity in this virtual machine or not? And if it can do that, you can also scale the size of the cluster. It's so much easier for the scheduler to do the right thing. It's also better for your application because if you don't specify limits, If you don't specify requests, Kubernetes does not know how much you need to be efficient. And in the worst case, it can just pack tons of pods into your cluster. So when you have a big increase in load on your system, it's packing more pods onto the same amount of resources, which means essentially you're getting worse performance. So you're trying to scale and be smart, but you're getting worse performance because you're not scaling out the size of the cluster because Kubernetes doesn't know it needs to do that. So you need to tell it how big or how much resources to allocate to your components. And yes, you can play around with setting requests to equal the limit, then you get guaranteed capacity. If the request is not equal to the limit, it's considered to be burstable. So in the worst case, so in normal use, you can actually be above your request, under the limit, but still above the request. But in the worst case, you'll be squished down to just your request. But at least you'll be squished down to something you specified, not to, yeah, I'm just going to jam more pods into this virtual machine and see what happens, because then your pods will probably get to low resource allocation. You can do some fancy tricks to reserve capacity and to prioritize pods. This, I think, is very important. I have a horrible war story. I'm going to save that for the pizza session here live for when this was not done, when it should have been done with priority classes. But the whole idea is that if you have multiple namespaces, or if you're sharing like one big cluster across many teams, you really want to be nice to the other teams so that you have some resource quotas in place, etc. And maybe you also need to reserve some capacity on your nodes for cluster health, because these are virtual machines that also run Linux and all kinds of daemons and stuff like that on there. So it's not just going to be your Kubernetes components, but Kubernetes will only manage the Kubernetes components. So you need to also have some kind of specification and say like, no, Kubernetes, you get to play around with this amount of RAM, for instance. This amount I'm saving for the system itself. You might wind up in the situation where you need to be a bit smart with the scheduler. You might need to tell the scheduler, like, okay, look, here's the database, here's its replica. The whole point for me to have a replica was that I want them to be on different machines, because if they're not on different machines, if you put them on the same one and that machine happens to like catch fire, that's no good. So they need to be on different ones. So you can specify that to the scheduler. You can set pod anti-affinity, which means like they're not friendly with each other. So like put them on different whatevers, like hosts or even availability zones. Same thing you can also do with something called topology spread constraints. If there's tons of traffic between two pods, maybe they should not be, in different availability zones. Maybe you actually want them to be co-located in at least the same availability zone. You can specify that too. And to help you do this, there's also a set of well-known labels that help you write these rules. So you can specify like host level, availability zone, region, stuff like that. If you run, say, an upgrade, a rolling upgrade of a deployment or a stateful set, maybe you want to make sure that Kubernetes can't like nuke all of your pods in a deployment at the same time and then start the new one. Maybe you want to have some kind of pod disruption budget, like it's fine for you, Kubernetes, to automatically replace 1 out of 5 pods at a time if you're planning to do something. I mean, if a host catches on fire, you can't really do anything about that. I mean, Kubernetes is not magic, but I mean, for sort of all the voluntary disruptions, you can actually specify how much of my deployment gets to be voluntarily disrupted. However, don't go nuts with this. So, I mean, it's deceptively easy to use. You can just say like, yeah, you don't get to disrupt this thing at all. But the problem is that might limit your admin's possibility of doing cluster operations, doing cluster administration. Because if they need to take down a node and you have a pod disruption budget that says, nuh-uh, don't do it, because a pod happens to be running there and that's the only one that gets to be and it can't be disrupted, you're preventing, say, security patching of the virtual machine that is part of your Kubernetes cluster. And that's no good. So you have to be smart about this, so don't go nuts with it, but it's definitely useful for something like a database where you really need to care that, you know, it's part of it will always be up at the same time. I know I'm slightly over time budget. Is that still fine, or? Cool. Yeah, I'm very close to the end. This is principle number. Excellent. Yeah. Yeah. Okay. Yeah. Yeah. Okay. Cool. Yeah. Cool. Damn it. Yes. No. All right. So when it comes to deployment, I know that a lot of people here are probably very interested in Kubernetes for its automation features. And one of those is, of course, that it's supposed to be easier to release and to operate software, right? That's the whole point. You want to deploy software and you want to have more automation. You want this to be smoother. So you want to have this sort of continuous integration and continuous deployment process. Now, what I've seen a lot of people do is still stick to some bad deployment strategy, which is sometimes called like stop the world, where essentially, you know, like you post like on your web page, like the system is down for maintenance. I mean, I still encounter that as a user sometimes. I hate that. I mean, you don't do that with many cloud services, but sometimes you encounter that still, and that's really annoying. What you'd rather want to give to your end users is, of course, that you have some kind of smart deployment strategies in place. Something like blue-green, where, I mean, maybe you have the old version still running of your component, and you also like side deploy the new one, and then it's just a matter of switching a load balancer to which one should get all the traffic. So if you discover that, something was wrong in the new version, you can just quickly flip it back so you have all traffic going to the old version instead. So that's something you can do. You can also run something called like a canary release, where, you know, like the canary in the coal mine, you know, the bird that, like, if it stops singing because it's dead, then there's dangerous gas, you know, that whole thing. The deployment strategy is that, say that you have 10 instances that serve traffic, so 10 instances of a component that serve traffic. If you can switch out one of them, so 10%, and direct 10% of traffic to the new version, if everything seems fine, then you can go ahead. If it does not seem fine, you actually run into problems, then you stop the rollout then and there. This is really difficult to get right. Because, I mean, if you release software, how many release software? Oh, duh. All of you release software. It's very difficult to get automated deployments right. Why? Well, you probably need so many of your deployments are going to be fine. Some deployments are going to include, say, a database schema update or something else that is really difficult to deal with. And then you have to go and do all kinds of smart tricks with like in-between versions of code that is compatible with both schemas and blah, blah, blah. So it's really difficult, but it's also hugely impactful if you can automate your deployment such that it's completely just happening. Why I use number 13 for this particular slide? Probably because it's difficult. That's yeah, I didn't even think about it, but now that you mention it, it actually makes tons of sense. Yes, yeah, that's a good idea, because number 14 was easier, yeah. It's about security, so the last two are about security. I love security. It's never supposed to be an afterthought, but I realize you can't start with security because people will feel like, oh God, don't talk to me about security. I always feel this bad feeling in my stomach when we talk about security. I know. Don't run containers as root. You probably have containers running as root right now in your cluster. No, you don't. I know why. Yeah, exactly. Yeah. I mean, there was a major bug about this just this January. So just 2 months ago, not even 2 whole months ago, there was a huge bug about this. So breaking out of a container, so you can break out to the host and then just do whatever you want on the host. Oops. So that's not good. But people say, but I have to run it as root. No, you don't. I swear that you don't. I swear that you can probably get away with using but just adding like 2 lines in your Docker file, one to like create a non-privileged user and another one to actually enable it. I'm sure it's going to work fine for you. And if it doesn't, if it really, really doesn't, because you really need some kind of capability that only root would typically have, there's actually a thing in Kubernetes where you can specify to drop all capabilities in Linux and then just add like the 1 or 2 back that you think that you need, but probably you don't. Okay? So please don't run containers as root. It's completely pointless. But I also know why, because I mean, like, just making up a number here, but like 95+% of all containers on Docker Hub are just running as root. And I also know why, because the first thing that anyone does when they create a container, what is that? Well, you install a bunch of packages, right? And root is the only one that gets to do that. So you install a bunch of packages, and then you just kind of forget that, oh yeah, my software, yeah, maybe it does need to run as root, but I mean, I'm kind of done now. I'm not touching my Docker file after this. So just please do. So touch your Docker file to make sure it doesn't actually run your software as root. And then, once you've done that, please also limit what pods can do inside your cluster. Because as I said before, Kubernetes is neither secure by itself nor by default. There's this thing called pod security policies. If you run an older version of Kubernetes, now it's called pod security standards. Kind of do the same thing. A bunch of rules that sort of limit what pods can do. For some reason, Kubernetes auto-mounts a service account token into your pod unless you specifically tell it, please don't do that. What does that do? Well, it gives your pod access to the Kubernetes API so that it can do smart things like automate things inside Kubernetes. Wonderful feature, but why is that the default? It doesn't make any sense. Who here, I mean, you all run stuff in Kubernetes, but who here actually automates things with the Kubernetes API, with the pods that you deploy? I see. I've done it, yes, is what I heard from one person. But I mean, it's not the typical use case, right? It's not what you normally do. I'd say it's like less than 1% of all software actually uses the Kubernetes API for something like this. So why would that be the default? It does not make sense. Network policies. So you want to have some kind of firewall rules between pods, and that's exactly what you can do. So nobody wants to sit and write an actual firewall rule with like IP addresses and stuff like that. But what network policy allows you to do is you can say that, okay, here's the backend component, here's the database. Only this backend gets to talk to this database. I mean, if I scale this up and down, those rules will apply to all instances of that component towards that service. So limit what can be done. Because again, for some reason, Kubernetes default, free for all. All pods can do whatever they want networking wise. They can talk to any other pod inside your cluster. That does not make sense. At least not to me. Finishing slide. So sometimes I get asked, okay, so thanks, Lars. You just talked for, well, slightly more than 45 minutes. What am I actually supposed to start with? I mean, you gave me 15 principles. Now, what am I supposed to go do? I think that the thing that will be sort of the biggest impact, obviously, is going to be the architectural decision to separate out stateful from stateless components. That's wonderful. If you want something that is super easy to get right, go with probes. I mean, that really helps you with automation. So go delete that liveness probe that doesn't do what you think it does, and you'll be a much happier Kubernetes user. Also, you can probably automate away certain things with this container lifecycle management. You remember the pre-stop hook, for instance, really useful. And you can probably also do really smart things with the pod disruption budget so that you never wind up in the situation that Kubernetes accidentally took down all your database replicas at the same time, because that would really suck. But be careful, because otherwise you might not be able to scale exactly, or your admin will be very mad because they can't actually administer the cluster correctly. All right. So, Number 9, resource requests and limits. Yes, absolutely. That can be a bit difficult to figure out exactly what you should put as your requests and limits. But there is a project called the Vertical Pod Autoscaler that tries to do this kind of by, mathematically informed trial and error. Yeah, go use that if you want. Sure. Yeah, so the comment here being that you can do this empirically by starting out larger than you think and then try to scale down the size until you find sort of the sweet spot. So yeah, exactly. Yeah, it's definitely. All right. Right, exactly. Yeah. Yeah, no, but absolutely. Yeah, I mean, it's something that makes sense. I mean, you have to figure out, like, okay, what does downtime cost, and what does increased resource usage cost, and try to find some kind of sweet spot between those two. Are there any questions that have come in from YouTube, Karen?
No, so we give for live people another 1 minute to super fast type some questions, because otherwise we will shut down the live streaming.
All right.
Is there any question from here? We have maybe 1 or 2 minutes, because pizza is there and everyone wants to get the pizza.
Yes.
Anyone questions?
If you mention pizza, obviously no one's going to have any questions.
Even live stream people doesn't want to ask questions because they think the pizza is really nice.
Yeah, exactly. Yeah. Well, thank you, live streaming people, for letting us have pizzas then. So, and thank you for listening to this talk. Thank you so much.
Thank you, Lars.
Thank you.
Great to see you here, and thanks for awesome presentation. I don't see any questions here, so let's not take it any further. So
no.
We will just say bye-bye to live streaming.
Yes.
So we
bye.
can count it off. So bye-bye.